Okay, everyone, let's pick it up with practice problem 3. On these, we're going to start calculating the probabilities that are associated with z-scores. So at this point, we know how to calculate z-scores. We've got that very simple formula to do it. But of course, the question is always, what's the probability, or is, I should say, the question is much more commonly, what's the probability of certain things happening rather than just calculate a z-score. So we're building up. You will find at the end of this lecture in the PDF this document. So it's on 2 pages. I have mine as a back-to-back. If I were bringing this to you guys in class, I would have these printed for you and to keep. They're really useful to have with you when you're doing homework and things like that, and you can use this on your next test for the probabilities for z-score. So I would invite you, maybe even right now, pause the video, go to the end and print both sides of both pages of these tables of z-scores, because it's going to be so much more handy just to be able to have that physically when you're doing homework or even following in the lecture, rather than having to scroll down to the bottom of the PDF and look at that and scroll back. And you don't want to have to do that. And you're going to want to have the printed version when you take a test with at home as well. The idea here is the formulas for the z-score, for the normal distribution, the formulas are not conducive for calculations. They are quite complicated. If you read that, in the first part of the lecture, we're not going to find probabilities with formulas like we did with, the uniform distribution, the exponential distribution, and even going back to like binomial, Poisson, right? Those had formulas to go with them to get probabilities. We can't do that with the normal distribution. It's just too much. So instead, somebody a long time ago took a lot of time and figured out all of these numbers. They're all rounded to 4 decimal places for these various z-scores. So the way you read it, the numbers down the left column give you the ones place and the first decimal digit of your z-score. The numbers across the top give you the second decimal place. And the numbers in the middle, once you locate it, that tells you the probability. And it's always, just like in the continuous random variable from last chapter, it's always the probability below that z-score. So whatever z-score you're looking up, it's how much area, or really what we're looking at is probabilities, how much probability is less than that z-score. On the other side, you're going to find the negative z-score. So, the ones place and the digit, and then the second digit. The negative z-scores are always to the left of 0, right? So whatever z-score you look up, it's telling you how much probability is below that, to the left. Okay, so we're going to practice these, of course. A motorcycle just drove by me. I don't know if you guys heard that through the mic or not. In my neighborhood. Okay, so 3A is asking for the probability that capital Z is less than 1.32. So I'm going to grab my formula sheet here. That's a positive, so I'm going to look at the positive side, and let's see if we can locate it. So I'm going to look 1.3, and then 1.32 is right there. 1.32.9066. So the answer to this one, 0.9066. If we were to plot 1.32, we'd be somewhere out here. And how much probability is below that? Over 90% of the data is below a z-score of 1.32. Okay. Let's go to part B. Probability that capital Z is less than negative 0.78. Okay, so I'll go to my table here, but now I need the negative side. Negative 0.78. Okay, I'm going to have to go way down here since it's increasing. So I've got negative 0.7, and let's try and get it all on the screen at once. Negative 0.7 and 8 is way over here, 0.2177. There's my answer to B. One thing you may have picked up already, if you are on the left side, your probability is always going to be less than 50%. If your z-score is over here on the right side, your probability is always going to be bigger than 50%. And we saw that here. Positive z-score, negative z-score, above and below. Okay. How about something like this? We kind of mix it up a little bit. The probability that z is greater than 0.55. And now how have we switched this? What's different? The table always tells us the probability less than the number, because it's always the area to the left. If they're asking about the area to the right, well, our table is not useful for that. And I've kind of made this note here. They're indicating the area above when they say greater than. How much is above 0.55? So what we have to do is say, well, our table doesn't know how to do that. So we're going to say this is 1 minus the probability that capital Z is less than 0.55. We're going to do the complement. We'll find the area below Z equals 0.55. Our table tells us that number. If we subtract it from 1, then we'll have the answer to what they're looking for. Well, what are we going to get? If we look up 0.55 on our table, okay, that's a positive z-score. So I'll go back here. Here's 0.5. 0.55 is right there. 0.7088. And so I think I didn't quite give myself enough room to answer this. That's all right. Let's kind of squeeze it in. 1 minus 0.7088 is 0.2912. And there we have it. So what did they do? Just kind of give you a visual for my verbal explanation a moment ago. We draw that normal distribution. It's kind of that sort of shape. We don't know what the mean is here. All we know is they're asking about a 0.55. So, maybe z equals 0.55 is something like right there. And maybe I'll even draw that line, make it easier. When they say greater than, they're asking what's this area above, right? So I'm going to find the area below. That's what my table tells me. Subtract it from 1, and that gives me 100%, and that will tell me the complement. What's the area above that value? And there we are. Okay. Part D. Now it has a z-value stuck between two numbers. What if our z-score, what's the probability of our z-score being between 0 and 0.55? Well, we saw similar things back in the last chapter. If I have my z-score here stuck between, I'm going to do the probability that z is less than 0.55 and subtract the probability that z is less than 0. Start with the bigger one, subtract the smaller one. That tells me the area, just the area that's stuck in between those values. And all right, well, turns out I used this number intentionally because we had just looked it up a moment ago. That is 0.7088. How about the probability that z is less than 0? If I go to my chart, hey, there's 0. 0.00 is exactly 0.5. I'll give all the decimal places, but yeah, 0.5. Why would it be that z equals 0? Why is the probability 0.5? Because if I'm right at the center at z equals 0, well, how much? Exactly half of the probability is less than that, right? And half is above as well. Okay, that makes sense. Well, if we subtract these, we'll have our answer, 0.2088 in this case. And I think you guys get it, but I'm just going to give you a drawing anyway because I like drawings. They're really helpful to make sense. So here's z equals 0. Here's our z equals 0.55 again. Let me draw the lines at both of those. This time they asked, how much probability is between them? So we took all the probability less than 0.55, subtracted the probability it's less than 0. That left us with just the area between. I think we've got one more, part E. Well, it's a similar question, but I give some different numbers. The probability that z is between negative 2.70 and 1.64. We're going to start this the same way. Less than the bigger one minus less than the smaller one. And then we're going to have to look up both of these and subtract them. So the 1.64, if you've got your table, that's on our positive side. 1.64 is right there. 0.9495. Negative 2.7, I'll have to flip it over. Negative 2.70, 0035. And if I subtract, let's see, you got my calculator here, 0.9495 minus 0.0035, 0.946, and I'll throw another 0 on there. There's the probability if you're between these two z-scores. Quite a bit. 94.6% of the data. Hey, maybe give yourself a drawing there, similar to this last one, but we'd be spread out pretty far if we plotted both those z-scores. We'd be capturing almost everything, over 94%. Okay, let's pause, and we will pick it up in the next one.